Okay, so we have the alkane. The first part of the name for alkane, it comes how many carbon you have in that molecule. The second part of the name, it comes that it indicates it belongs to this family of organic molecules. And when it belongs to this family of organic molecule, any molecule that belongs to alkane family is going to have carbon-carbon single bond only, is made of only carbon and hydrogen. So alkane is a hydrocarbon that has only carbon-carbon single bond. Carbon-hydrogen single bond, we don't have to say it because in chapter 1 we talked about number of bonds that hydrogen can form, and that was only one bond. Hydrogen cannot form more than one bond. So any hydrocarbon, that means that it's carbon and hydrogen only, it carries only single bond, is going to be alkane. The first part of the name, it comes from number of carbon. The second one, as I said, indicates the number of hydrogen, or it indicates the family name for this compound. If there is only one carbon, the first name is going to be met. So met stands for one carbon, and then we have A-N-E, methane. If we have one carbon alkane, there must be 4 hydrogen, because if we say met, that means there's only one carbon. How many hydrogen do we need? We already know from chapter 1, carbon is tetravalent. It must have 4 bonds, and if it must have 4 bonds, it's understood that we are going to have 4 hydrogen single bonded to carbon. So CH4 is the first member of the family of alkane, which is the first family of hydrocarbon we are talking about. The next one is CH3, CH3. This is a condensed formula. There is a carbon-carbon single bond there. There's carbon-carbon single bond and 3 hydrogens on each carbon. Now, carbon is tetravalent. 1 bond is satisfied with another carbon, and 3 bond is satisfied with hydrogens. So we have 4 domain or 4 electron group, 4 single bond. We talked about counting the domain or electron group. Single bond counts as 1 electron domain or 1 electron group. So we have 1, 2, 3, and 4 single bond. So we have 4 electron group here. We have 2 carbon for molecule of ethane and total of 6 hydrogen. So with the 6 hydrogen total for the 2 carbon, each carbon gets because we must have that carbon-carbon chain anyway to begin with. And then we need 3 hydrogen for the carbon on the right side and 3 hydrogen for carbon on the left side to satisfy with the octet rule, or 4 bonds for each carbon. Now, if we have 3 carbon, how many hydrogen we must have in order to satisfy each one with each carbon with 4 bonds or the octet satisfaction? We are going to add 3 hydrogen to the beginning of the chain. Very good. 3 hydrogen to the first carbon. How many hydrogen do I need for the carbon in the middle? 2 only, because already has 2 bonds to the other carbons. And the carbon on the left side, it requires 3 more hydrogen because already has 1 bond here. So we need 3 more. If we count the total number of carbon, it ends up with 8. For 3 carbon, we end up with 8 hydrogen required to saturate every carbon with 4 bonds. We learned about the term of saturated, unsaturated in inorganic chemistry or general chemistry. that which apply to solution. If solution can still take more of the solute, that means that compound is that solution is unsaturated. But when you can't dissolve any more of the solute, let's say you start with a cup of water, you add salt, and you add enough salt that no more salt dissolves, or no other salt, no extra salt dissolves, that means that solution is saturated. In organic chemistry, when we say saturated, that means you cannot add any more hydrogen. You have added enough hydrogen to satisfy every carbon with 4 bonds. Number of carbon, it comes from the name of the compound, but number of hydrogen, if it's alkane, that means saturated, means that all carbons are satisfied with the octet rule or the 4 bonds using enough hydrogen. So you can add more hydrogen to the molecule. So this alkane with the 3 carbon, the prefix is pro, and family name for this is ANE. What does ANE stand? It means that this compound is saturated. It belongs to family of alkane. So we had C1H4, C2H6, C3H8. For C4, if we follow the same pattern, is going to require 10 hydrogen. So in general, now we are going to have a general formula for alkane. For any number of carbon, number of hydrogen is going to be a 2n plus 2. So this is the general formula for alkane. So alkane CnH2n plus 2. That's the general formula. So if we have 1 carbon, number of hydrogen is going to be 4. If we have 2 carbon, number of hydrogen is going to be 2 times 2 plus 2 is going to be 2 times 2 plus 2, which is going to make it 6. If we have 3 carbon, is going to be 8. We are going to work on the number of hydrogens for now, the ratio, and then I will cover all the names for you. For 1 carbon is met, 2 carbon is et, 3 carbon is going to be prop, and then I would show you the spelling, so there's no problem with that. So if we have 4 carbon, we already said about 10 hydrogen. If we have 7 carbon, how many hydrogen should we get? For 7 carbon, 16. We are following that formula, the general formula, 16. And if we have 10 carbon, number of hydrogens is going to be 22. Perfect. So what we need to know for alkane so far, alkane has a family name of ending with the or suffix of A and E. The first part of the molecule, it comes with the number of the carbon, and the second one has a meaning that this compound belongs to the alkane family. Alkane family, the ratio of hydrogen to carbon is 2n plus 2. For every carbon, you get a 2n plus 2 hydrogen. The general formula is CnH2n plus 2. There is only single bond for alkane, so there is no double bond, no triple bond, no CO double bond, no other heteroatoms, because we're talking about hydrocarbons. It's only carbon and hydrogen, all single bond. Okay, now you know we are talking about alkane and one new family, or the first family of organic molecule. I want to tell you like how we are going to learn each family. when we are going to learn about one family of organic molecules, there are 4 aspects. The first one is going to be what is the functional group and how the structure of this molecule look like. Second, what is physical property? What causes or what affects the physical property of any compound? What affects the physical property of a compound? Physical property like boiling point, melting point, solubility, structure. What else? Mass, intermolecular forces. Intermolecular forces. Now, intermolecular forces affects the physical property, the structure, mass, the type of bonding is going to affect the intermolecular forces. So intermolecular force determines what should be the melting point, or how should be the melting point, relatively high or relatively low. Now the structure and the size or number of carbon atoms is going to affect the intermolecular forces. So based on the intermolecular forces, we can predict if the boiling point or melting point or solubility, how it's going to be. So let's look at a couple of these examples. If we have CH4 minus 160 boiling point, ethane is going to be minus 89, and propane is minus 42. And based on this pattern, we see that the boiling point is increasing. Now, what type of intermolecular forces we have for methane? London dispersion, very good. For propane, also London dispersion. For ethane is London dispersion. So what makes how London dispersion is affected? What are the factors that affects the value or magnitude of London dispersion forces? One is the size of the carbon. The greater the mass is going to be greater the London dispersion forces. And secondary factor was that the branches. So for a 4-carbon straight chain versus 3 carbon in a straight chain and 1 as a branch, these 2 is going to have different boiling point, because branching is going to lower the boiling point or lower the intermolecular force of London dispersion. As you increase the number of carbon, or as the size is increasing, intermolecular force is going to be stronger, and the boiling point is increasing. Because it's negative value, you could see that the pattern is going to increase. Okay. With the common, we have butane for 4 carbon, isobutane for 4 carbon that is not in a straight carbon chain. So they started with just naming compounds with 1 carbon. They said methane, then is ethane, then is propane. Propane, how many isomers do we have for propane? We learned about isomers before. So let me go to this page. How many isomers we can write for methane? Just 1, right? There's 1. For ethane, when it's a CH3, is there any other different connectivity can we use for this molecule? No. So there's only 1 molecule. There is no isomer or pair of isomers. If you have 3, is going to be also 1, because if you change this and you say I'm going to start like this, and then CH2 and then CH2, still in IUPAC or structural formula, the connectivity is the same. So these two molecules are same molecule. These two are equal because connectivity is the same. So for methane, ethane, propane, we have one structure only. For one carbon alkane or two carbon alkane, three carbon alkane, there's just one possible structure. When it comes to 4 carbon, with the 4 carbon, you could have CH3, CH2, CH2, CH3. Straight carbon chain, enough number of hydrogen to satisfy each, and this is called butane, 4 carbon, but, and then A and E, because there's no double bond, no triple bond, butane. The other possible structure for this molecule is if you have 3 carbon in the carbon chain and 1 carbon as a branch added to the second carbon. This molecule is not the same. These two are not the same molecule. They are not the same because this carbon has 4 straight carbon chain, this carbon has 3 straight carbon and 1 as a branch. Why these two compounds are not the same? How do you call two compounds exactly the same if they have same connectivity and have same physical property? We already learned from intermolecular forces that this molecule A is going to have greater boiling point compared to compound B. So if the compound A has greater boiling point than compound B, these two cannot be same compound. And if they are two different compounds, we must name them differently. So then they had to come up with a different name. So traditionally, or they were using common names. And they said, okay, if it's a straight chain, we are going to call this like N-butane. That's normal butane. That means normally carbons are going to follow each other. And if one methyl group is on carbon number 2, yes, the type of isomers is constitutional or structural isomers. Either one is correct term to be used. If there is a methyl group on carbon number 2, they said they came to agreement that we are going to use the iso prefix, and then there are 4 carbon here. If we say isobutane, what does isobutane means? It means that we have a total of 4 carbon, but structurally is different from normal butane. For isobutane, we have a methyl group on carbon number 2. So the carbon number 2 carries a methyl group, and they name this as isobutane. These two are the only 2 structures you could find with 4 carbon and 10 hydrogen for C4H10. These two are the only 2 isomers. Now, if we move from 4 carbon to 5 carbon, then the number of possible isomers increase. So for C5H12, 1 would be normal butane. Then we know about the other name. If there is a methyl group on carbon number 2, and with this methyl group on carbon number 2, how would you call that? The second one. So if you call the first one N-pentane, how should we call the second compound? Pentane means 5 carbon, all single bonded. This is 5 carbon, all single bonded, but is not all a straight chain. And we learned that if we have a methyl group on second carbon, this is the first carbon, second carbon. If we have a methyl group on second carbon, the prefix of iso can be used to distinguish between a normal pentane and the second structure where we have methyl group on carbon number 2. So we call this one as isopentane. A and E means all single bond, pent means total of 5 carbon, and iso means that methyl group is on carbon number 2. There's another possible structure here. Good question. Cis and trans, it doesn't exist when you have all single bonded. Remember I said rotation around carbon-carbon single bond is free. So we don't have cis or trans when it's all single bond. The other structure for 5 carbon, you're welcome, for 5 carbon is if we have 3 carbon in a row, 1 carbon on top, 1 carbon below. So we have total of 5 carbon. This is just C is not the double bond. We have total of 5 carbon, but the structure is not isopentane. At the time that they discovered this compound, it was new to them, and because it was new to them, they called this as a new pentane. They said this is a new compound, so they called it new pentane. So for pentane, we have normal pentane, isopentane, and neopentane. And with the new pentane, means that you have on carbon number 2, you have 2 methyl group. This is common name. So it's like example of if you were planning to name your son, after your name. So if you're Frank and then you want to name your son like Frank Jr., then if you get, a second child and his boy and his Frank, what would you name it? So you go from Frank Sr., Frank Jr., and then IUPAC, which stands for International Union for Applied and Pure and Applied Chemistry. They kind of had to come up with rules and say, okay, so in that case of example for naming, so if you say Frank Jr. 1, then Frank Jr. 2, Frank Jr. 3, you kept your promise that if you had any son, you would name Frank. And then with number 2, 3, 4, you solve the problem like how we call this, different children that they still have same name, but one after the other, so you're just keeping your promise. IUPAC, the same thing, they came up with the rules and said, okay, we cannot keep just coming up with new names, because if you have 2 isomers for 4 carbon, now you have 3 isomers for 5 carbon. If you have 6 carbon, the number of isomers is going to increase. So if they said this one as a new pentane for a molecule that has 4 carbon in a row and 2 carbon on the 2 methyl group attached to second carbon, but this is 4, they cannot call this one new hexane. So they had to come up with the rules to name the compound with systematic name, so it's not common name anymore, and numbers are used. Oh, okay. Branching, we get to that. We get to that soon. Branching. Okay. So we have a prefix that gives the substitutions, or methyl group. That was just a question. That's one of the substitutions. We have the base for any name that shows the number of carbon, and then the suffix, it shows what family they belong to. So there is a crowded table we have here, and then we get like more space on the next slide that I will give you examples. But let's look at some of these examples already. If you have 1 carbon, CH4, for every carbon you get 2N plus 2, so CH4 is methane, and that's the formula. For 2 carbon, molecular formula is C2H6, based on following the general formula of CN, H2N plus 2. Molecular formula would be C2H6, the condensed formula CH3CH3. If you have 3 carbon, it's going to be propane. For 3 carbon to be propane, it must have 8 hydrogen to be saturated, and then this is just a straight carbon chain. For 4 carbon, the butane is written here for a straight carbon chain, but isobutane is not, because now moving to IUPAC naming, and we don't have to use the definitions for iso unless you're dealing with the branch, which we talk about branching soon. So 5 carbon would be pentane, 6 carbon hexane, 7 carbon heptane, and 8 carbon is octane, 9 carbon is nonane, and 10 would be decane, so like a decade. 11 carbon undecane and 12 carbon dodecane, and that's what you need to know. Okay, up to 12 carbon only. There are other examples here. You don't have to memorize the rest. Okay. So if it's 1 carbon, the prefix is going to be met. 2 carbon would be et, 3 carbon prop, 4 carbon is but, 5 carbon pent, 6 carbon hex, and 7 carbon would be hept, 8 carbon oct, 9 carbon non, so nonane, and then 10 carbon would be dec, for decane. If it's all saturated, it's going to be alkane, so methane, ethane, propane. See that they are all following the same suffix. Butane, pentane, hexane, heptane, and octane. Before we start naming organic molecules or alkanes using IUPAC rules, I have to introduce to the branching. If we have CH4 as a methane, if CH4 loses 1 hydrogen, you have to draw a free, like a hand here. That means it's ready to attach to something else because it's not satisfied. So if you see CH3 attached to a major carbon chain, this CH3, the name of the CH3 is extracted from the CH4. So it starts with met and has lost, like if we count the number of groups for methane is 4, CH3 has lost 1 group or electron group, and I used to say has lost 1 hand, it becomes ill, and we call it methyl. Methyl means that it's 1 less hydrogen compared to alkane that is coming from this number of carbon. So I need your help to tell me what would be the alkyl name that is coming from this compound if it loses 1 hydrogen. So if we have this compound, this one that I'm circling now, the name of that compound is, because of the 2 carbon is et, this compound that is circled now, et, is everything there, all the hydrogens needed to make them satisfy is there, so it's going to be ethane. Now, you are correct about the name for the branch, and the name for the branch with the box is going to be extracted from the alkane name that is ethane, is going to be et-il. So we have the il indicating that this is not a compound, is ill, has lost the hydrogen, but it's coming from the original name of ethane, with losing hydrogen is going to be ethyl. So if it's a 1 carbon branch, it's going to be methyl. 2 carbon branch is ethyl. If it's 3 carbon branch, so we start with the original compound. Alkane is CH3, CH2, CH3. This is propane. Very good. Propane. Now, if is going to lose 1 hydrogen, it becomes CH3, CH2, CH2, and the name for this is going to be propyl. So we have the "il" extension added. Now, we have hydrogen on the carbon 1, we have hydrogens on carbon 2. What about if the hydrogen that is lost is from hydrogen 2? Then you have to name it differently. Just like a Frank Jr. 1, the other one has to be 2, because you cannot have same name for 2 structure. So if the hydrogen is lost from the second carbon, now it looks like the carbon 2, if you count this, there's the methyl group on carbon number 2. So this is going to be iso. You have total of 3 carbon is going to be pro. And is missing 1 hydrogen is going to be il. So we have isopropyl. Isopropyl, if you have 3 carbon branch, but is attached from carbon number 2. What about 4 carbon branch? 4 carbon branch, you're going to have CH3, CH2, CH2, CH2. If it's attached from this one, is going to be butyl. Now, if it's attached from second carbon, from the second carbon on butyl, okay, we are going to stay with the definition of the iso for methyl group on the second carbon. That is going to make it easier for you. Isobutyl means that there is a second, on the second carbon you have a methyl group. But if it's attached from the second carbon, that means you have CH3, CH here, CH2, CH3. Basically, I should say that the only magic here is to memorize it because we don't have too many branches. This is called sec-butyl. Sec-butyl, a straight carbon, but is attached from the second carbon. So if you see the attachment from the second carbon on the 4 carbon chain, it's called sec-butyl. How does isobutyl look like? I hope you wrote down all of these, and we should have one slide that has them all, but it's better if you write them. You write them all. You need to write methyl, ethyl, propyl, isopropyl, butyl, that's 5, sec-butyl, and isobutyl. So only 7 branches that you have to memorize it. So make sure you know the name for all 7 branches that you need to memorize. The last one is isobutyl. Isobutyl looks like this. Isobutyl looks like CH3 and then CH2. So just write the structure, write the name next to it, and practice using it. And when you practice using it, you get to learn the the name, memorize the name. Basically, you have to memorize the name. Now, we are going to practice some naming of alkane now that we know the name of branches, and then I'm going to talk about some of the rules. Then we will read the rules step by step. Okay, so that way you have some practice, and then it makes more sense. You know what does it actually mean if we say one of the rules. Isn't that sec-butyl? I'm going to name this isobutyl. I would draw the sec-butyl on this slide so you could compare it. So this is an isobutyl, is attached from the first carbon. This is a primary carbon. That means attached to one other carbon. That's a primary carbon with like a 1 and then this little degree sign that shows primary in organic chemistry. So we have primary, secondary, and tertiary. A primary carbon is a carbon that is attached to one other carbon only. What would you call this carbon here? This carbon, how would you call it? Primary, secondary, or tertiary? Tertiary, because it's attached to 3 other carbon. If it's attached to 3 other carbon, it's going to be a tertiary carbon. So then you have sec-butyl. Sec-butyl is attached from secondary carbon. So that sec, it doesn't come from second carbon. It comes from secondary carbon. So if you have the branch that looks like this, CH3, CH, but is attached from this carbon, is going to be sec-butyl. So this is called sec-butyl. Is attached from secondary carbon. Sec-butyl. Now, if you had a carbon that looks like this, now you made me to increase that number to 8. So if you have this, how would you name this one? Ham is a branch. You see you have 3, 3, 3, that's 9 carbon with 9 hydrogen with 4 carbon. So basically a C4H9, very good. C4H9, that's missing 1 hydrogen, because if it was a H10, it wasn't missing carbon. It was, you would call it like butane, and you didn't have to call it as a branch. But if it's missing 1 hydrogen, you have to name it as a branch. So it's going to be butyl. But if it's a butyl, is it normal butyl? Is it isobutyl? Is it sec-butyl? Or does it look like this and you call it T-butyl? A T-butyl, that means a tertiary carbon. Okay, tertiary carbon. That means that it looks like a T. So if you have a carbon here, carbon here, carbon here, this looks like a T. If this is attached to a major carbon chain, this looks like a letter T. So T-butyl, but that T doesn't come from the T shape. It comes from a tertiary carbon attached to 3 other carbons. So this is a tertiary carbon that is going to attach to major carbon chain. So make sure you add this also to your list. T-butyl. Okay, let's start naming some compounds. We already know the name for this compound. Can you just name it for practice? The first compound, A. What's the name for compound A? Propane. Propane. Very good. Propane. For compound B, we're not going to use the isobutane as the common name. We are going to use the IUPAC rule to name this compound. The first rule in the IUPAC, it says find the longest consecutive carbon chain. Find the carbon chain. So if I start numbering, can start from left to right or right to left for this molecule is not going to make a difference. But in general, you have to number from the side that is closer to the branch. Since this branch is in the middle, it doesn't matter to right. It starts from right to left or left to right. So it's going to be 1, 2, 3. When you are numbering, like you are using a marker, you are using your marker should just slide. If I was going to number this, I have to basically move my marker, come here and number this 4. So it's not consecutive. It's not connected to number 3. So I cannot, I have a choice of going 1, 2, 3 down here. Or I have a choice to go to 1, 2, 3 with the red color. I cannot go 1, 2, 3 red color and then jump down here and say 4 because 4 must be connected to 3, not to 2. So one of the first rule is find the longest carbon chain, number it, then find the location of the branch. So if we go with the red color numbering, the branch is on carbon number 2. Name the branch first, and then give the name for the long carbon chain. What is name of this branch that is on carbon number 2? This is methyl. Why do we call this methyl? Because it's coming from one carbon. It's a one carbon branch. There is only one name for it. There is no mention. Methyl. Methyl, and then is the main carbon chain is 3 carbons, so it's going to be propane. Methyl propane. Now, we normally have to give location to the branch. In this case, it doesn't matter if you put 2 or not, because any way you count it is going to be carbon number 2. Just to make sure that we are following the rules, we are going to write 2 methyl propane. So branches should come in first, and then the main carbon chain. This is one of the initial rules. There are like 5, 6, 7, 8 rules, different rules, and we are going to learn one at a time. So major, or the first step, is find the longest carbon chain, number them. Yes, is methyl because it's a CH3. Methyl because the group or the branch is CH3 and is attached to carbon number 2. Okay, that's one example. Next example, we have CH3, CH2, CH3, and we have a CH3 here. Now, how many carbons do you have in the longest carbon chain? 4. 4, very good. Very good. Should I start numbering from left side or right side? From the right side. Why should I number it from the right side? 1, 2, 3, 4. If I number from the left side, it's going to be 1, 2, 3, 4. And only 1 is correct. If I number from the right side, the branch, which is methyl group, is going to be on carbon number 2. This way. And that is the correct way. If I number from the left side, branch of methyl is going to be on carbon number 3, and that is wrong. So we cannot use the red sequence of numbers going from left to right because it's going to assign greater numerical value to the location of branch. So rule number 1, find the longest carbon chain. Rule number 2, number from the side that will give you the lowest numerical value to your branch. So we have to number it from right to left. So we have carbon number 2 carrying the methyl group. Then give the location to your branch. Give the location. What carbon carries the branch? The carbon that carries the branch in this case is carbon number 2. So we'll say 2. Use a dash line to separate number from letter. And that is very strict. You must use the dash line to separate the number from letter. So 2 dash, name the branch first, methyl. So it's 2 methyl. And what would be the main carbon chain? In this case, it would be butane. So the name would be 2-methylbutane. Longest carbon chain first, numbered from the side that you get the lowest number, numerical value assigned to the branch. You have one branch only. So you have to go from right to left. Give the location. This is the location to the branch. Name of the branch first. Then major or main carbon chain. 2-methylbutane. Next example. I'm not going to write the number of hydrogen. I trust that. Why was butane? Because the straight carbon chain or the longest carbon chain had only 4 carbon. That's why it was butane. And there was no double bond, no triple bond, so it's butane. I hope that I answered your question. I'm going to assume that you already know there are enough hydrogen to cover these carbons with 4 bonds each. So I'm not going to write the hydrogen bonds or show the hydrogens. How many carbon do we have in the longest carbon chain in this case? 5. Which side should I number it from? Left side or right side? From the right side. Very good. So we are going to number 1, 2, 3, 4, and 5. How many carbon, when I indicate my longest carbon chain, how many groups do I have that did not take the number? Anything that doesn't take number is going to be counted as a branch. So I have a branch up and one branch down here. The name for this branch, the top one is a methyl group, but the bottom one is, what's the bottom one? Methyl. So we have methyl group on top and a methyl group at the bottom because each one has only 1 carbon. That but was just to call the attention. It's not, it was just a trick. So both of them are the same. So we have methyl group on top and methyl group at the bottom. If you have, that's another rule for IUPAC. If you have more than 1 branch of the same, you can use the numbers and separate the number with the comma. So we have methyl group on carbon number 2, so and another methyl group on carbon number 2. So instead of me saying 2-methyl and then the 2-methyl, I can say 2, comma 2. So comma is used to separate numbers in IUPAC. What should come next? Is it a letter or a symbol, number? What should I bring next? Can I write 2, 2, and then methyl? Is this correct? Is something missing? A dash line, very good. A dash line is missing here. So it would be 2, comma 2, and then dash line and methyl. but I have two methyl groups here. Since I have two methyl groups, I'm going to have to add the prefix of di. So I have 2,2-dimethyl. That means there's a methyl group on carbon number 2 and a methyl group on carbon number 2. So I have two methyl group on carbon number 2. And the main carbon chain in this case is going to be pentane, because it's 5 carbon. Next example. How many carbons do I have in the main carbon chain? 6. Let me count it because 1, 2, 3, 4, 5, 6. No. 8. 1, 2, 3, 4, 5, 7. Okay. 7 carbon. And what is that the 7 carbon? The 7 carbon, I'm just going to draw a line that 7 carbons. See? When you're counting, you should be able to draw a line also. Just a consecutive or continuous line. You cannot break the line. Now, I cannot include this carbon. I cannot include this carbon. These two is to be left out, and they are named as a branch. Now, I have two choices. Should I go from left side here, or should I go from the bottom down here to number my main carbon chain? Go from the bottom. 1, 2, 3, 4, 5, 6, and 7. Why are they left out? When you say main carbon chain, your carbons must be continuous line. It can bend, but they must be continuous. So if I draw a continuous line, I'm just going to double this line that I draw already. If I draw this continuous line, it does not include this carbon. It doesn't include this carbon. That's why we call them branch, that they are attached to the main carbon chain. So we have a methyl group on carbon number 3. We have a methyl group on carbon number 4. So I have two choices. I can say 3-methyl and then 4-methyl heptane, or I can combine the two. So if you have identical branches, you can combine the numbers and separate them with a comma. So it would be 3, 4 dash, because both of them are methyl, is going to be dimethyl, heptane. Heptane. 3,4-dimethyl heptane. See if you can match the name with the structure. If you have questions, let me know. If not, I go to the next example. Ethyl group, sure. Why not propane instead of heptane? Because we have 7 carbons, so for 7 carbon we must have hept. Hept determines what is the size of the main carbon chain. So our main carbon chain has 7 carbon, so it must be hept. Hept shows how many carbon you have in the main carbon chain. Okay, one more. So let's look at this rule first, and then I will look for the example for ethyl and isopropyl for you. We find the longer continuous carbon carbons, and you are going to number the longest carbon chain beginning with the end that is nearest to the substituent. You want to name the group that is attached to the carbon chain first and give the location to the alkyl group using a number. If you have more than one alkyl group, you can combine them if they are identical. And if you are combining two alkyl groups, you would say di, then alkyl group, three alkyl groups, you would say tri, and then the alkyl. Other examples. The carbon chain here is bent, but still is continuous. So when we are talking about carbon chain, it doesn't have to be straight, but it must be continuous. And if we follow this continuous line, there is one branch only, and that branch is going to be on carbon number 3 in this case. I already had examples. I'm kind of moving faster from this to get to your question. 3 on carbon number 3, you have a methyl group, so this is going to be 3-methyl. Because it's 6 carbon in the major carbon chain or main carbon chain, is named hexane. So 3-methyl, that means on carbon number 3, there is the methyl group. Hexane means that you have 6 carbon in the major carbon chain. So for this compound here, if you try to go, this is a better example. It brings a new rule. You want the smaller number to be attached or assigned to each of the branches. But if you have a possibility for more than one branch or greater number of branches, you should go with the greater number of branches. Like for this example that you have here, for this example, if you go 1, 2, 3 down, 1, 2, and then go, you can't go straight that way because it's going to end up in only with 4 carbon. Then you would go down, would be 5, then you say 6. You can go straight to say 7 and 8. So we have 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. That's one choice. The other choice is to go 1, 2, 3, 4, 5, 6, and 7. So if you say 6 and 7 down, what would be the difference? The difference is if you go down, like the second choice here, if you go down, number of branches, you have 1, 2, 3, and 4 branch. If you go straight here, you would get only 3 branch. Which one is preferred or follows the IUPAC rule is the one with greater number of branches. So when possible, with the carbon chain with the equal length, because the length of the carbon for alkane, for the main carbon chain, the number of carbon in the main carbon chain takes the priority. So if you have equal length, you would use the chain with the greatest number of branches. So because here you have 7 carbon, 4 branch is going to be the right structure. And this kind of, we are going to number this and name it. Which way should we number? So we already know that this is not the right one. This is not the right one. So with the major carbon chain, should I number from down, up, or this way? Which carbon should I start with? I'm going to call this A or B. Which one should I start with? With the B? Okay, let's number both. Okay, let's number both and then see what would be the total numbers that assign to branch location, that gives the location of the branches. With the blue color, I'm going to go 1, 1, 2, 3, 4, 5, 6, and 7. My branches are on carbon number 2. There is a branch on carbon number 3. There is a branch on carbon number 4. And there is a branch on carbon number 5. So it would be 2 plus 3 plus 4 plus 5, and total would be 5 and 5, 10 would be 14. If I go from up down, so I hope you have them in your notes. So I'm going to go up down, but I'm going to make it a little bit more clear. 1, 2, 3, 4, 5, 6, and 7. The first branch is on carbon number 3, so it's going to be 3. Second branch is on carbon number 4, 4, 5 plus, and next one is 6. So this is going to be 3, 10, 15, 18. If you add them all up, it's going to be 18. If I'm correct, this is going to be 18, but if you from bottom up, it's going to be 14. That's why there's only one correct way of numbering, and that would be numbering from bottom up. Why bottom up? Because the total number is going to be less. If you add up the location for all the branches, it's going to add up to smaller numbers. So when we number this 1, 2, 3, 4, 5, 6, and 7, now we can help me to name this, and that gives you the ethyl branch here. So we have methyl. Since this is a new language for you learning, you can go step by step. You could write everything on the side, all the branches. So this branch, and you can just cross one at a time, so you can actually make sure that you're not going to miss anything. You have a 2-methyl, so write the 2-methyl. Then this branch is the ethyl on carbon number 2 ethyl. You have 3 ethyl. Then on carbon number 4, you have a methyl group, so it would be 4 methyl. Then on carbon number 5, you have 5 methyl. Which ones can be combined? Identical branches. So I have a 2-methyl, 4-methyl, and 5-methyl. I can combine those 3 together, and I can say 2, comma. You must use comma to separate the numbers. 2, 4, comma, 5, dash line. You must use a dash line to separate the number from letter. Because we have 3 methyl groups, now it's going to be tri-methyl. So we gave the location to the 3 methyl groups. We have to also give location to the ethyl group. So to bring the ethyl, I have to first give the location for ethyl, so I have to bring a number. But since I end up with letter and I'm bringing number, I have to use a dash line. You should always use a dash line to separate the number from 3 as well. Let me see. Did I miss it? No. 3 is this one. 3 has an ethyl group attached to it. This is my carbon number 3, is number 3. And then there is a group that is attached, box in now, and that is ethyl group because it's a 2-carbon branch. So 3 ethyl. On carbon number 3, no, the connected CH3, this doesn't count separately. It's from the carbon that is directly attached to this green box. the first carbon that is attached to green box is coming from a 2-carbon branch. So we name that ethyl group. So on carbon number 3, we have ethyl group. Carbon number 2, we have a methyl group. Carbon number 4, we have methyl group. So 2, 4, 5 trimethyl, 3 ethyl, 3 ethyl, and then we have 7 carbons, so it's going to be heptane. Now, which one should come in first? Ethyl should come in first, or methyl should come in first. That's another rule for IUPAC. If you have different type of branches, you have to follow the alphabetic order. And in this case, ethyl must come first. Okay. So ethyl must come in first. So to write the correct name, you are going to write this again. You are going to say 3 ethyl dash 2, 4, 5 trimethyl and heptane. And that would be the name for the compound. Write in your own, with your own handwriting, because with this stylus, and I have very small screen, because that's the only device that I can write on the screen. It makes it hard for me. So write it yourself, neat, with your own writing, so you can recognize what it is. Is a 3 ethyl dash line 2, 4, 5 dash line trimethyl heptane. There is no need for space between a methyl and heptane. You just say methyl heptane. Okay. So if you have more than one type of branch, first you have to give location to the branches in a way that the smallest number set is assigned. We had a smaller number set for this case because we end up with 14 number set. That means adding 2 plus 4 plus 5 plus 3. Versus in this case, we end up with 18, which wasn't correct. After your numbers are assigned, then you look at the branches. If you have identical branches, combine them. If you have different branches, write them indicating location first in alphabetic order. Okay. For butyl branches, you have N-butyl, or because it's a primary carbon, you just say butyl. Isobutyl, when you have a primary carbon, but methyl group on carbon number 2. Sec-butyl, a secondary carbon is attached, and T-butyl, when a tertiary carbon is going to be attached to a major carbon chain. And then you have your methyl, ethyl, propyl, and then butyl with pentyl, if you had it. Okay. So you have this box, table 2.2, for you to memorize name for branches. So if you know the name of branches, then it's easier to number. Chapter number 3, especially naming alkane, you have to learn very well, because if you don't learn this, you won't be able to name the compounds in chapter 12, 14, 16, and everything else. So these are the baby steps in naming, just like naming of the elements in periodic table. So these are the components and the rules that is going to give you IUPAC name for the first family, and everything else. Like if you go for alkene, there's only one rule that is being added. So if you go to alkyne, there's only one rule to be added. So if you learn these rules by heart, so you know it already, so moving up to the next chapters, naming would be much easier for you to move on, to learn and move on. So you want to number the longest chain. You number from the side. For this example that we have, you number from the side that lowest number is attached or assigned to the branch. So if you number from this side, you're going to 1, 2, 3, 4. So methyl would take number 4. If you number from top here, it would be number 3, and that's why you're numbering from the top. So if you have only one substituent, you just number from the side that is closer to that branch. If you have more than one branch, then you have to number it in a way that you get a better number set. So if you number from the left to right, you would get 1, 2, 3, 4, 5. So you get a 3 plus 5 here. If you number from right left, you would get 1, 2, 3, 4, and then 5 and 6. So it would be 4 plus 6. This is going to be 8. That is going to be 10. And that's why you're not numbering from right to left, and you're numbering from left to right. Any questions? Any questions so far? No? Perfect. I'm sure these are rules the same way you have to memorize. It's a new language. It takes practice, but it's not complicated. That's one thing that I can assure you is not complicated learning organic naming. With the respect that we have, how many, like 13 millions of them, is much, much easier than learning naming inorganic compounds, which you already learned and passed, and now for you is like piece of cake. So don't be intimidated, don't be afraid of naming compounds or organic chemistry just because there are too many of them, but the rules are just one set of rules, and with the practice it's going to be very easy because it's not complicated. Just do not think that it's complicated. It's going to help you better to move on, really. Okay, we have 3 branches here. We combine the 3 branches. One branch is on carbon number 2, one is 5, one is 7. So you would say 2, 5, 7, and you use trimethyl. Comma is used to separate the numbers. Dash line is used to separate the number from letter. And then it's 3 methyl groups, so you would say trimethyl. And 10 carbon in the main carbon chain, it would be decane. Dec and then ane. But you don't write it separate, you bring it together. Why do we name this isopropyl? Why is this isopropyl? Because you have the propyl and then you have isopropyl. If it was attached from the first carbon for a 3 branch, it would be propyl. Because it's attached from the second carbon is isopropyl. And the best way, because there are just limited number of branches, is to memorize them. And this is called T-butyl because you have a tertiary carbon. The total number of carbon is 4, and you have a tertiary carbon that is attached to the main carbon chain. So we have T-butyl group. Do you number from the right to left or left to right? You count it first, 1, 2, 3, 4, 5, 6. If you go from left to right, it would be 1, 2, 3, 4, 5. Then this is not correct and this is correct. Going from left to right is correct. Okay. If you have equal number of carbon on the carbon chain, then any way that will give you greater number of branches, yes, is isopropyl because it's in the middle carbon. Yes, is a 3 carbon, that makes it propyl, and then iso is going to be in the middle. So if you have same equal number of carbon in the carbon chain, you have to number from the side or in a direction that gives you maximum number of branches. Okay. Questions? You've been quizzed 2 or 3? 3. I think we will talk about it. I don't know exactly now, but if it's too early, before we finish the chapter, I will postpone it, just like I postponed the chapter 2 quiz. The schedule is tentative, but you will know it at least 24 hours before you have a quiz. That's at least. Dimethyl for dimethyl 5-propyl 5-propyl octane. Okay, let's draw this structural formula for this compound. If the name is given to you and you want to draw the structure, like when you are writing the name, you have to start with branches. But when you are drawing the structural formula, you have to go from backward, basically. So you have to first draw 8 carbon chain. 1, 2, 3, 4, 5, 6, 7, and 8. 2, 4, 6, 8. Numbered 1, 2, 3, 4, 5, 6, 7, 8. Then place the branches. On carbon number 2, there is a methyl group. On carbon number 4, there is a methyl group. On carbon number 5, there is a propyl group, so it would be C, C, C. You see, if you follow the procedure, if you make a procedure for yourself and you follow the procedure, it's going to be much easier. So first step, if the name is given and you want to draw the structure, first step is to draw main carbon chain. Step 2, you number it. After 4 C's, 4 carbons. See, it says for propyl, prop means 3, right? Prop is 3, so it's going to be 3 carbon for but it's attached to carbon number 5. First, I say octane, I have 8 carbon. Based on this name here, I draw 8 carbon chain. And it's ane, that means all single bond. Then I follow the branches and I just place the branch in proper place, because this name is telling me what? This name is telling me there is a methyl group on carbon number 2 and a methyl group, and a methyl group on carbon number 4, and there is a propyl group on carbon number 5. So I put the methyl group on carbon number 2, methyl group on carbon number 4, and propyl group on carbon number 5. Now, should I draw it up here or down here? Because rotation around carbon-carbon is free. It doesn't matter if it's up or down, so either one. You can draw up or down. You can draw up or down, but just one. One methyl group attached to carbon 2, and one methyl group on carbon 4, and one propyl group on carbon number 5. Okay, very good. Your quiz starts, I believe, now. So I'm going to stop the lecture here. I let you take the quiz, and we're going to start the lab for those of you who are in the lab at 10 o'clock. Okay? If you have any questions, you could, there was just one question I didn't answer, and I'm just going to read that question, look at that question, and then I'll let you go. And for anyone who doesn't have a question, you can go ahead and start the quiz. The quiz is open, right? Will you have to draw the structure from the name of a... Oh, I didn't read the question and then I had the answer. That's great. Quiz is open. Perfect. If you have question, you could ask question. If you have no questions, start the quiz. You can leave the session, start the quiz. And I'm recording. I'm stopping